Hello everybody, today we are going to discuss how can we find the first derivative of a function f of x using the basic definition of derivatives. F prime of x or f dash of x, which is the first derivative of f, can be obtained by using this basic definition. Limit f of x plus h minus f of x over h, where h is a very small value, which means h approaches 0. Here we have example. If f of x equals x to the power 3 minus x, find f prime of x using the basic definition. First of all, f prime of x equals, here we have the rule, f of x equals x power 3 minus x. So f of x plus h, f of x plus h here, you have to replace each x by x plus h. So instead of x power 3, we have to write x plus h power 3. Instead of x, we have to write x plus h minus f of x minus f of x over h, and h approaches 0. Expand the brackets. So we have here x power 3, the first one, x power 3 plus 3x squared h plus 3x h squared plus h squared minus x minus h minus x power 3 plus x over h. Simplify this expression, so we have 3x squared h plus 3x h squared plus h power 3 minus h. As we can see here, h is a common factor, so we can take common factor, or you can divide this expression by h. So we have 3x squared in the last line here, 3x squared plus 3xh plus h squared minus h. When h approaches 0, find the limit when h approaches 0, substitute h equals 0, so we have 3x squared minus 1. Another example. If f of x equals root x, then find f prime of x, find the first derivative using the basic definition. Step number 1, write the rule. Here we have f of x plus h. F of x equals root x, so f of x plus h equals root x plus h minus f of x minus root x over h. This is the limit problem, which includes root minus root, so you have to multiply by the conjugate, as we discussed in the lecture of limits. You have to multiply by the conjugate. The conjugate here is root x plus h plus root x over, and multiply the conjugate down, root x plus h plus root x. The first root times the first root, so the root will be deleted, so we have x plus h, root x times root x equals x, and h here times this expression. Here we have x minus x equals 0. So we have h. This h can be deleted with this h, so you can cross these two h's here. So you have, after deleting the h from above and from below, you have this expression. Now substitute h equals 0 here, so you have 1 over 2 root x. Another example. Find derivative of sine x. If f of x is sine x, now find its derivative. d dx, it means the derivative of sine x. So write the rule, f of x plus h minus f of x over h. F of x plus h here, which is sine x plus h. Instead of x, you have to write x plus h. So this is f of x plus h minus f of x over h. Now, sine x plus h, we have a rule for sine x plus h. Sine x plus h equals sine x cosine h plus sine h cosine x minus sine x over h when h approaches 0. So we can divide this problem, this limit problem, into two limit problems. As we can see here, sine x cosine h minus sine x, there is a common factor between the first term and the last term. So collect sine x cosine h minus sine x over h in the first part here. And in the second part, we have sine h cosine x over h. So sine x here is a common factor, as you can see here. And here, limit sine h over h cosine x. Limit cosine h minus 1 over h. When h approaches 0, we have an old rule, which is limit cosine x minus 1 over x when x approaches 0 equals 0. The same here, limit cosine h minus 1 over h when h approaches 0. So this term has been deleted. And we have here sine h over h. Its limit when h approaches 0 equals 1. And so we have the final answer is cosine x.